So, hello friends, once again in our online lecture series, we have completed our previous point, that is types of reactions. Before that, we have completed the reaction intermediates also. Okay, now here next point is of various effects. Okay, now you have field effect, you have resonance, then inductive effect. There are a number of effects, so we have to see one by one. Okay, so in these effects, next one point is the field effect. Okay, what is uh, field effect? Okay, so it is observed in the organic compounds. Now what is the field effect? Now see here, field effect means what? It is the polarization of a molecule through a space. Polarization of the molecule through space. Okay. Now it is totally different effect from the inductive effect. Okay. We have to see that effect. But as you know, inductive effect is the polarization of the sigma bonds, okay, that depend upon the adjacent atom or group, nature of that atom or group. But here, uh, please remember, it is a polarization of the molecule, but through space. Through space, or we can say the solvent medium, solvent, is known as field effect. Now see here, first point, it is a result of an electric field. It is a result of an electric field produced by charge localization. Produced by charge localization in a molecule. Okay. Now it is a weaker type of effect. Means it is a not stronger effect. It's a very weaker type of effect, and it decreases with the distance. As distance increases, this effect is decreases. Okay, it's a very weaker type of effect. Now how it will produce in organic molecules? So for that we have to see some examples. Now first is nitrogen carries positive charge 1, 2, 3, CH2, CH2, CO, CH3. Okay, so this is the carbonyl group, and this is the ammonium salt containing nitrogen having positive charge. So actually both the groups are what? Strong electron withdrawing. Okay, they withdraw the electron towards itself. But if you will see here, this ammonium salt is more electron withdrawing than this carbonyl. Okay, so it withdraw the electron towards itself, and in this way polarization, okay, polarization of molecule occur. मॉलिक्यूल मध्ये काय होतं? पोलरायझेशन होतं थ्रू स्पेस or by a solvent medium. Then this effect is known as what? Field effect. Now this is first example. Second example, if we see here this is fluorine, CH2, CH2, CO, CH3. Now as you know, fluorine is the most electronegative element in the periodic table. Correct. Now its electronegativity is 4. सगळ्यात जास्त काय आहे? इलेक्ट्रोनेगेटिव्ह एलिमेंट आहे, आपल्याला माहिती आहे. सो इट withdraw the electron towards itself. Okay, and therefore the polarization in the molecule increases. Now it will also withdraw electron towards itself, but more withdraw from the fluorine side, and therefore polarization creates in the molecule. So this is field effect. So this effect operates through space or solvent molecules. Remember one thing, inductive effect is different and field effect is different. Now, it depends upon geometry of the molecule also. Okay, geometry of the molecule also. For that, you have to see one best example. See, this is one compound. If you see here, this is benzene ring, CC bond. This is also benzene ring. Again, acidic group COOH. Okay, and these are the bridge carbon. You can say CH, 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 which links these two rings. Okay. So if you see here, now this is also hydrogen, hydrogen. Now here is Cl, and here is also Cl. Means chlorine is there. So what will happen in the field effect? See here, this is also a acid, but here it's a weak acid. Now what is its pK value? pK value is 6.07. Now you know, pK value, it indicates the acidity of carboxylic acid. Higher the value of Ka or lower the value of pK, that acid is what? Stronger or more acidic. So what happened here? See here, now these hydrogens are on this side, okay, left hand side, and these fluorine atoms, if they are present on the right hand side, then there is a partial bonding, you can see here, which is formed between the Cl minus and H plus, and therefore its acidity decreases. Now see, same example, see here, same example, no change, but what is the change in the structure? Hydrogens on the left hand side. Here, if chlorine atom present on the left hand side and hydrogen atom present on the right hand side, then it acts as a, now this molecule acts as a stronger acid. How can we say? We can say based upon its pK value. Now see here, what is its pK value? It is 5.6. It is lower than this value. That means this acid acts as a strong acid and this acts as a weak acid. So why this thing happen? So answer is due to the field effect. Due to these chlorine atoms present on right hand side, there is a partial hydrogen bonding, you can say, between hydrogen and chlorine, and therefore it cannot donate H plus very easily. Okay, and therefore it acts as a weak acid. But here you can say hydrogen are present on this side, therefore no hydrogen bonding takes place, and therefore here this acid, it can donate this proton, okay, more easily, and proton donors are nothing but what? Acid, and here it acts as a stronger acid. So this is a best example of what? Which effect? That is field effect. Okay, this is a best example. Okay, so we have seen here field effect, then we have to see the some more effects also. So okay friends, now here we are seeing the second effect, that is inductive effect. You know very well this effect, you have learned it, but still we are saying this effect, that is inductive effect. You know I effect. Okay, so what is the inductive effect? You know very well, it is observed in the single bonded compounds, sigma bonded compounds. So what happens in inductive effect? Polarization of sigma bonds. Polarization of sigma bonds increases due to the adjacent polar covalent bond. ठीक आहे, म्हणजे काय होतं, ऍडजस्टंट ला जर एखादा पोलार कोव्हॅलेंट बॉन्ड असेल तर त्यामुळे त्या दुसऱ्या बॉन्डची पोलॅरिटी काय होते, वाढते, इन्क्रीज होते, इंड्यूस होते, आणि यालाच आपण काय म्हणतो, इंडक्टिव्ह इफेक्ट. ठीक आहे, बऱ्याचदा आपण लेक्चरमध्ये याच्याबद्दल तुम्हाला मी सांगितलेलं आहे. ठीक आहे, सो सी हियर, इट इज the effect of neighboring atom or group. याला काय म्हटलं जातं? It is an effect of neighboring atom or group. Now suppose X, one atom or group X and Y. If Y is more electronegative than X, then Y withdraw the electron density towards itself. So Y carries negative charge, X carries positive charge. Okay. So this is just representation of inductive effect. Okay. Now it occurs in a single sigma bonded compounds. Okay. It does not occur in the multiple bonded compounds like pi bonded compounds. And it is a permanent effect. Most important point. So electron density in a covalent bond, the sigma covalent bond is just shifted towards more electronegative atom or group. So it is not a field effect. Actually in both the effects polarization increases, but in field by space, and inductive effect by polarization increases through a bond. Okay. Now see here one example. Here I am taking one example, ethyl chloride CH3 CH2Cl. As you know, chlorine is more electronegative than carbon. So chlorine withdraw the electron density towards itself, so it carries minus delta charge. This carbon carries plus delta, this carbon carries plus delta 1. From this withdrawal, now it will withdraw this bond also, electron density, and therefore this bond is also, this bond becomes also polar. Polarization of this bond increases due to adjacent polar covalent bond, and this is nothing but what? Inductive effect. Okay. See, second, this is acetic acid CH3COH. Now it governs the acidity of carboxylic acids. If electron withdrawing groups are present, then the acidity of carboxylic acids increases. Now see here, this is acetic acid COOH. pK value is 4.76. Okay, but here if you see, if I replace one hydrogen atom, suppose this hydrogen I replace with the Cl, then its pK value 3.7. So that means this acid, chloroacetic acid, is more acidic than simple acetic acid. Lower the pK value, stronger the acid, and higher the pK value, weaker the acid. Okay. So why this thing happens? असं काय झालं? So see here, chlorine is more electronegative. Now it will withdraw the electron density towards itself from this CO bond, CC bond, and then CCl bond, and therefore its pK value decreases. Okay. So there are two types of inductive effect, that is plus I and minus I. Plus I means positive inductive effect, minus I means negative inductive effect. So which atoms or groups show plus I? So generally electron donating groups show plus I, positive inductive effect. Okay. So which atoms or groups are donating? So generally all metals, sodium, magnesium, aluminium. Okay. And all alkyl groups. You know the methyl, ethyl, propyl, tertiary butyl, isobutyl, all the alkyl groups. There are some other groups also. R, CH3, OH, hydroxyl group, NH2, amino group, OR, alkoxy group, NHR, substituted amines, etc. These show plus I. Okay, positive inductive effect. Exactly opposite of this, minus I, that is negative inductive effect. So electron withdrawing group, AWG means what? Withdrawing or acceptor group show minus I effect. Okay. So which groups generally show the minus I? So there are number of groups, like you can see here, nitro, NO2, cyanide, fluorine, acid, sulfonic acid, aldehyde, ketone, ester, etc. These are the groups which show minus I effect. And you know the acidity of carboxylic acid is governed by minus sign effect. That means if strong electron group is present, then acidity increases, and if donating group is present, acidity decreases. In halogens, fluorine, chlorine, bromine, and iodine. As you know, fluorine is the most electronegative element in the periodic table. So, in presence of fluorine, the acidity of carboxylic acid increases because it stabilizes the carboxylate ion which is formed after the donation of H plus by that acid. Okay, so this is overall about the second effect, inductive effect, totally different, and we have seen its two types also. Okay, then we have to see the next effect. So, hello friends, we have seen two effect, field effect, inductive effect. Now, next one is the steric effect. It is also known as steric hindrance, steric crowding, or bulky groups if present. Okay, so steric effect. So, it is the size or bulk that governs the size of reactant. Okay, it is the size or bulk that govern the size of reactant. You can say it is steric hindrance. It is nothing but you can say steric hindrance or steric crowding. Steric crowding by bulky groups. Okay, so if a certain group that is very bulky, and due to that if some reactions doesn't occur, then that effect is known as what? Steric effect, steric crowding, steric hindrance, one on the same meaning. So it is a steric hindrance, steric crowding by the bulky groups. Okay, now see here. To understand this effect, there is a one best example of bromination of aniline. If we take aniline and if you add bromine in water, okay, then as you know, in aniline NH2 is a electron donating group. So electrophilic substitution occurs at these positions, 2 ortho and 1 para position. Okay, so we will get a product like this. 2,4,6 tribromoaniline. Numbering start from this group NH2 1, 2, 3, 4, 5, 6. So we'll get this product. Okay, white product, a bit of white product, 2,4,6 tribromoaniline. But if suppose, listen carefully, if suppose I want only parabromoaniline, I doesn't want the substitution which occurs on ortho position, then what I have to do? लक्ष देगा मला फक्त पॅराब्रोमो पाहिजे, मला ऑर्थोब्रोमो ॲनिलीन नको आहे. I have to block these ortho positions. Then what I have to do? मग मला काय करावं लागेल? Then see the path, reaction path. First of all, aniline I have to treat with the Ac2O Py means acetic anhydride and pyridine. मला नायट्रोजनचं N असैलेशन करावं लागेल, बरोबर आहे. Aniline when treated with the acetic anhydride in presence of pyridine, then it will converted into acetanilide, which is a neutral compound NHCOCH3. Now see here, this lone pair is in conjugation with this carbonyl group. Okay, so I have introduced here this acyl group. This is what? Nothing but acylation. This process is acylation. I have introduced acyl group, bulky group. So I have increased the what? Steric hindrance on that NH2 group. Then I will do the bromination, bromine acetic acid. Then see here, due to these bulky groups, 2 orthos are hindered, or you can say they are blocked. So bromination occur, at para position. So I will get here 4-bromo or para-bromo acetanilide, and on hydrolysis, acidic or alkaline hydrolysis, finally I will get here para-bromo aniline or 4-bromo aniline. So this is what steric effect in this reaction. Steric effect, steric crowding due to the bulky groups. जर हा ग्रुप नसता तर ब्रोमिनेशन कुठे झाला असता 2 ऑर्थो अँड 1 पॅरा. पण आपल्याला ऑर्थो नको आहेत म्हणून आपण काय केलं, असाइल ग्रुप जो आहे बल्की ग्रुप तो इंट्रोड्यूस केला अगोदर आणि मग ब्रोमिनेशन केलं. ठीक आहे. तर याला आपण काय केलं, प्रोटेक्ट, याला प्रोटेक्शन अँड डिप्रोटेक्शन केमिस्ट्री असं सुद्धा म्हटलं जातं. We have protect the NH2 group by acylation, then the bromination, and then deprotect is we remove this group by what, hydrolysis, acidic or alkaline hydrolysis, and finally I will get para-bromo aniline by specified product. Okay. So it is called regioselective bromination at what, para position. Regioselectivity occurs here. Okay. Now see here, steric hindrance, it will affect the acidity of acids, basicity of bases on number of compounds, number of reactions. This effect will affect. Now see, this is the NN dimethyl, one type of aromatic aniline. Now here CH3, 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 bulky groups are present. Okay, and you know the basicity of this aniline is decreases because its lone pair is not easily gives to the acid, and it does not occur the coupling reaction also. Now see here, because of steric hindrance means retardation, delocalization doesn't occur. Now this lone pair doesn't delocalize, and therefore and hence its coupling is failed. Coupling of this compound is failed. You know the coupling reaction, it generally the aniline, okay, react with the other compounds to by coupling reaction, and aza products are formed. Okay. Okay friends, so see some more examples of steric effect, that is steric crowding. Now see here, this is one example, picric acid. You know this is phenol, which group is there, NO2, 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 picric acid. IUPAC name 246 trinitrophenol. Now it will act as a stronger acid, strongest acid. Okay, it is what, strongest acid of phenol, picric acid. Now you know, you can see here this lone pair. Okay, it's lone pair shift here, nitro groups. It is a strong electron withdrawing group, and it will withdraw the electron density towards itself. And due to this 3 NO2, 2 on ortho and 1 on para position, they stabilize the phenoxide ion which is formed after the donation of H plus ion by phenol. You know generally phenol is a weak acid, but if strong electron withdrawing groups like nitro are present at its ortho and para position, then its acidity increases, and this is the strongest acid of phenol, that is picric acid. Okay, so this is one point. Now second one, this is picramide. Instead of OH group, NH2 is there. So generally it should be what? It should be acts as a base. हा base पाहिजे होता, पण हा base नाही. त्याचं reason काय? की ही lone pair free आहे का? नाही. ही lone pair इकडे जाईल, हा pi bond इकडे, and due to this NO2 group, it also withdraw electron density towards itself. Now see here, at 2 ortho and 1 para position, bulky group is present, that is nitro. So basically it acts as an what? Neutral molecule. and not base. Now see here, this is NN dimethyl 2,4,6 trinitroaniline. This is 2-methyl group. This is nitro, nitro, nitro. So it acts as a base because these two methyl groups are donating, and therefore this lone pair is slightly free as compared to here, because here only withdrawing groups are present. Steric crowding is also increases. Here also steric crowding increases, but the reason is what? These two donating groups, this lone pair can easily donate, and therefore its basicity decreases. Okay, so it is 40,000 times stronger base than the picramide. Okay, so this is overall about the steric effect, or you can say what? Steric hindrance, steric crowding due to the bulky groups. So we have completed this effect here. Okay, thank you.